Overview and objectives. Children, it is human nature to organize things. Cooks painstakingly organize their spices into various groupings. Kids dump out their piggy banks and sort their riches into piles of coins of different denomination. Similarly, scientists began attempting to organize the elements in the late 1800s when they knew of about 60, which led to the formulation of the periodic table. Let's learn about this periodic table in detail. Hello children. Today, we will be discussing about the modern periodic table. As you all know, the modern periodic table is basic to the sciences and is so familiar that popular songs have ever been written about it. So, it's absolutely necessary to have a detailed knowledge about it. Let's start our journey. Learning objectives. In this topic, we will learn about the modern periodic table. Periodic table. Mendeleev's periodic table. Dmitri Mendeleev was the first scientist to create a periodic table of the elements similar to the one we use today. This table showed that when the elements were ordered by increasing atomic weight, a pattern appeared where properties of the elements repeated periodically. This periodic table is a chart that groups the elements according to their similar properties. The most important difference between Mendeleev's table and the modern periodic table is that the modern periodic table is organized by increasing atomic number, not increasing atomic weight. Why was the table changed? In 1913, Henry Moseley learned that it is experimentally possible to determine the atomic numbers of elements. Before that, atomic numbers were just the order of elements based on increasing atomic weight. Once atomic numbers had significance, the periodic table was reorganized. Modern periodic table. Henry Moseley in 1913 modified Mendeleev's periodic table by taking atomic number as the fundamental property of an element instead of atomic weight. Atomic number is the basis for modern periodic table. Atomic number is the number of protons in the nucleus. It is also equal to the number of electrons in the atom. Modern periodic law states that the chemical and physical properties of elements are periodic function of their atomic numbers. The most common used periodic table is the long form of the periodic table, which is called modern periodic table. The main features of modern periodic table are: elements are arranged in the increasing order of atomic numbers. There are 7 horizontal rows called periods and 18 vertical columns called groups. Modern periodic table. Groups in modern periodic table. The vertical columns are known as groups, and there are 18 groups in the modern periodic table. First group. Alkali metals are placed in the first group in the modern periodic table. Hydrogen is also placed in the first group, although hydrogen is not an alkali metal. Second group. Alkaline earth metals are placed in the second group in the modern periodic table. Elements placed in first and second groups in the modern periodic table are collectively known as light metals. Third to 12th group. Transition elements are placed from third to 12th group in the modern periodic table. 13th group. Metals are placed in the 13th group except boron, which is a metalloid. 14th group. Carbon, silicon, germanium, tin and lead are placed in this group. Among them, carbon is a non-metal, silicon and germanium are metalloids, and tin and lead are metals. 15th group. Nitrogen, phosphorus, arsenic, antimony and bismuth are placed in the 15th group, among which nitrogen and phosphorus are nonmetals. Arsenic and antimony are metalloids, and bismuth is a metal. 16th group. Oxygen, sulfur, selenium, tellurium, and polonium are placed in this group, among which oxygen, sulfur, and selenium are nonmetals. Tellurium is a metalloid and polonium is a metal. 17th group. Nonmetals are placed in the 17th group. Since halogens are placed in this group, hence this group is also known as group of halogens. 18th group. Noble gases are placed in the 18th group. This group is also known as zero group. Periods in modern periodic table. At present, there are 7 periods in the modern periodic table. First period. This is known as very short period as there are only 2 elements, that is hydrogen and helium. Second and third period. There are total 8 elements in each of the second and third periods. These periods are known as short periods. Fourth and fifth period. There are total 18 elements in each of the fourth and the fifth periods. These periods are known as long periods. Sixth period. There are total 32 elements in sixth period. This period is known as very long period. Seventh period. This period is known as incomplete period. Blank spaces in this period are supposed to be filled by the elements discovered in future. Division of elements into S, P, D and F blocks. This classification of elements depends upon the types of orbitals, that is S, P, D or F, into which the last electrons of the atoms of the elements enter. S block elements. In these elements, last electron enters the S subshell of their outermost energy level. These include elements of group 1 and 2. P block elements. In these elements, last electron enters the P subshell of their outermost energy level. These include elements of group 13 to 17 and 18. D block elements. In these elements, last electron enters the D subshell of their outermost energy level. These include elements of group 3 to 12. F block elements. In these elements, last electron enters the F subshell of their outermost energy level. These include elements of 2 series at the bottom of the periodic table, that is lanthanides and actinides. The S and P block elements, except zero group elements, are called as normal or representative elements, while D block elements are known as transition elements. Lanthanides and actinides, that is F block elements, are called as inner transition elements. Position of elements in the modern periodic table. Elements are placed in groups according to their valence electrons and placed in periods according to the number of shells present in them. Example: hydrogen, atomic number 1. Electronic configuration of hydrogen, K1. Valence electron 1. Number of shell 1. Position in periodic table. First group, first period. Sodium, atomic number 11. Electronic configuration of sodium: K2, L8, M1. Valence electron 1. Number of shell 3. Position in periodic table: first group, third period. Carbon, atomic number 6. Electronic configuration of carbon: K2, L4. Valence electron 4. Number of shell 2. Position in periodic table: 14th group, second period. Neon, atomic number 10. Electronic configuration of neon: K2, L8. Valence electron 8, that is equal to 0. Number of shell 2. Position in periodic table: 18th group, second period. Trends in modern periodic table. Number 1. Valence electrons. Number of valence electrons remains the same while moving from top to bottom in a group. Number of valence electron increases while moving from left to right in a period. Valency first increases up to 4 on moving from left to right in a group and then decreases up to 0. Valency of an element is the combining capacity of an atom of an element to acquire noble gas configuration. It is equal to the number of electrons lost, gained or shared during the formation of chemical compound. Valency of an element is equal to number of valence electrons if equal to or less than 4. Valency of an element is equal to 8 minus number of valence electrons if more than 4. Number 2. Atomic size. Atomic size increases on moving from top to bottom in a group and decreases on moving from left to right in a period. Number 3. Atomic radii. Atomic radius increases on moving from top to bottom in a group and decreases on moving from left to right in a period. Number 4. Metallic character of elements. Metallic character decreases on moving from left to right in a period. Number 5. Reactivity of elements. Reactivity of metals decreases as the tendency to lose electrons decreases on moving from left to right in a period, and reactivity of metals increases as the tendency to lose electrons increases on moving from top to bottom in a group. Tendency to lose electron is also known as electropositive character. Thus, electropositive character decreases on moving from left to right in a period and increases on moving from top to bottom in a group. Reactivity of nonmetals decreases down the group because of the increased atomic size, and tendency to gain electrons decreases. On moving across the period, their reactivity first increases due to the decreased metallic character and increase in non-metallic character. Metals like sodium, magnesium are placed towards the left side of the periodic table. Metals are electropositive as they have the tendency to lose the electrons to form the bonds. Non-metals like sulfur and chlorine are placed towards the right side of the periodic table. Semiconductors like silicon and germanium are in the middle of the periodic table. Uses of modern periodic table of elements. Knowing the atomic number, it is easy to locate and predict the chemical properties of any element in the periodic table. The position of the element in the periodic table will help us to write its electronic configuration and identify the valence electrons in the atom of the element. It reveals the similarities, differences, and trends in chemical properties of the elements clearly. One can easily write the molecular formula and predict the compound formed by the given two elements with the help of the periodic table. Merits of modern periodic table. A. All the elements are arranged in the increasing order of their atomic number, which is the fundamental property of elements. B. The place of isotopes is justified fully based on atomic number. C. Metals and non-metals are separated properly in the table. D. Systematic grouping of elements into 4 blocks has made their study simpler. Summary. Students, we have thus come to an end of this topic on modern periodic system. Hope you all now clear with the concept. Tomorrow we will meet again with yet another interesting topic. Bye for now. Children, we now got a detailed explanation about the modern periodic table. Hope this explanation will be helpful to you. Summary. We have learnt modern periodic table, groups in the modern periodic table, periods in the modern periodic table, trends of the modern periodic table.